2.1a, we are talking about functions, different types of functions and their graphs. But today, 2.1a, we are specifically talking about the quadratic functions. First things first, the standard form of the quadratic function is ax minus h squared plus k, the vertex being h comma k. So let's talk about each individual part of this. The a determines the slope and whether it is positive or negative. So whether it is right side up or flipped upside down. So a is slope or positive, negative. The h determines whether how much it is going to the right and going to the left. Remember, if it is negative, it is going towards more of a positive. So if it's negative, it is counterclockwise. If it is negative h, we are dealing with a right motion, right? So if it's x minus something, we're moving to the right. However, if it is positive, we are going to the left. Lastly, we have our k. Our k is exactly what it is. If it is negative, we are going down. Our k determines our y factor. So if it's negative, it's going down. And if it is positive, we are going up. If we are given, let's say, a simple quadratic and they want us to turn it into standard form, we have to complete the square. So let's say we are given x squared minus 3x plus 5, and they want us to turn that into a standard form. So what we need to do is complete the square. I'm going to split up the 5, so take the 3x plus, I'm going to put this in parentheses, the 5 is going to be by itself. Half of 3 will be 3 halves. Then you square that. Squaring that will be what? 9/4. So 9/4 here. We add 9/4 on the inside. We have to subtract 9/4 on the outside. Now we can complete the square here. This is x minus 3 halves squared, 5 minus 9/4. 5 is what? 20/4. 20/4 minus 9/4 is 11/4. So that would be our standard form for that equation. So here, if we were to give a graph, if we had to pick a graph one way. So if we had one that says negative x minus 1 squared plus 2, plus 2, let's change that into 2. I know my vertex is at 1, 2, so over 1, up 2, I know it's going down, so it's up, down, and then down 3, and it should look like this. What if we had a different type? Let's give another example. What if we had, let's say, 2x plus 2 minus 3? So this means whatever the 2 is, my vertex is going to be at -2, -3. So -2, -3 starts here. I know this is a positive parabola going up. So that means here, but the slope is increased by 2. So if, squared here. so then everything is going to be double the amount. So this one, where it'd be 1, it'd be 2. Where it would go up 3, we would go up 6. So the other side would match accordingly, and so this would be that parabola right there. What if we have an equation where the variable is on the inside of the parabola, right? So what if we had, let's say, a 2x plus 1 squared minus, let's say, minus 3. Well, here, notice that the 2 is on the inside. That means that our variable, if it was taken on the outside, right, it would be squared. So instead of everything multiplying by a factor of 2, it actually multiplies by a factor of 2 squared, which in this case would be 4. Okay, so that is how we would approach that. Vertex would be what, at -1, -3, -1, -3, but instead of going up 2, we would go up 4, 1, 2, 3, 4, and then all the way. So I think this is going to be a very, very thin, very emancipated looking parabola. And that is all we would need to know for our parabolas.